Welcome to Speaking of Service, the podcast that uncovers practical ways to grow service revenue, control costs, and improve customer satisfaction. If you're looking to innovate, gain a competitive edge, or just learn about the latest service trends, you've come to the right place. Today, Anthony Maffa meets with James Penney, Chief Technology Officer at Device Authority, to share his experience and to give us an overview where AI and machine learning fit into organizations today.
Well, good day, everyone. This is Anthony Maffa here for Speaking of Service. Thank you for joining us for session 2 of our 3-part series on security. Today, I have joining me James Penney. James is from Device Authority. James, welcome to the show.
Thank you very much for having me, Anthony.
And I'd like you to just give a very short introduction of who you are and what you do for Device Authority.
Sure, I'd be happy to. So my name's James Penney, obviously. I'm the CTO of Device Authority. I've been doing security for about 17 years now, in various different aspects, but obviously most recently is all around IoT. Worked very closely with PTC on a number of things for a number of years, actually, as well. And so obviously, as the CTO, I'm responsible for a lot of the product strategy and the vision and the sort of deeper technical goings-on at Device Authority, and responsible for our Keyscaler platform, which is an IoT sort of identity and access management, and kind of security control center for IoT devices at scale.
So what we're talking about here, though, and there's nothing to make light of, right? Machine learning is an absolutely important part of modernizing and streamlining the process of service, but an AI environment's a little higher level than that. It's starting to make that machine think even more human-like, not just being pattern recognition.
Yeah, and it's really the AI is really the umbrella term for a lot of those things. I think the reason for the uptick. I think now there's an expectation, especially on tech companies, to do something with AI, if you want to call it that. And even I was reading recently that in Q2, I think it was this year, of earnings calls, something like 67% of companies who mentioned AI in their earnings calls that saw their stock price rise. Effectively, their share price went up almost instantly. And you only have to look at NVIDIA, for example, as well, to see how well it's kind of gone for them in terms of referencing AI. I mean, they're very focused on it, and I think their hardware is doing great things. But you can see the impact that it has and how that expectation makes its way almost into the boardroom and then trickles down a little bit from there.
So we know that AI and machine learning really rely on data to be fed to them, and that's what an IoT system is doing. An IoT platform is really accumulating that data and feeding it into to that environment. So I'm going to use that data to learn. But what about the impact of AI and ML on that environment, on that IoT platform, right? There's a relationship between these two. One's giving it the data. What's the other one doing for that environment? What's AI and ML doing to that environment?
If we just take a step back a little bit, one thing that you have that's very apparent with IoT and associatively with the platforms is that you have this big scale problem, right? At the end of the day, there's a scale problem in terms of the number of devices you deploy versus, I think, the number of people that you probably have to manage them. And there's a couple of different ways, I think, to dissect what machine learning could really do for the sort of platform side. I will say this as a slightly kind of general statement, is I think it's inevitable in every IoT enterprise use case, at least. And not just from a security perspective, which I'm sure we can get onto later, but the fact that there's, like I was saying, there's just too many devices and not enough humans. And I think when you start to want to get this value from this data, the only way you're going to be able to do that is really through those processes, right? So if you take a look, we talk about some examples. So if you take a look at predictive analytics, right? That seems like a pretty sort of low-hanging fruit for IoT, I think, because that's really where you're going to start looking at it and saying, that part's going to fail within a certain number of hours based on other data that we might have seen. And I think the interesting evolution, and I'm sure you would have seen it too, is if you actually went back and looked at or reviewed IoT use cases from like 5, 6 years ago, whatever it might be, 7 or 8, something like that, they were quite binary, right? So it was, I just want to get data. You take like an oil well or something, a connected pump for like a well. It used to be, I just want to know how many liters I'm putting out or whatever it might be, or gallons, obviously, and how much I'm producing each day. And now it's, well, how is that compared to all the other wells and fields that I have deployed, and how is that production stacking up, in terms of other metrics? And I think IoT has like naturally progressed onto these more difficult problems to answer, that doesn't come from these sort of very static processes that I think people are generally used to implementing. And the data is a core part of that, and the platform is a massive part of that whole process. Ingesting that data, helping to organize it, feeding it into those processes, so being the presentation for the warnings and what you're seeing, and the output and the visualization of that data is incredibly important. And I think the two go hand in hand really well. But if you can have a really good ML process, but if you're not seeing it or visualizing it or connecting it to anything else, then there's probably not much point in really doing it. So, I think it really helps to drive a lot of the value that you get from the IoT platform itself. And it's not only that, it's, if you could take a look at some other sort of examples of this machine learning, like image and video processing, right? So the idea of monitoring, we were referencing it on a previous conversation, but monitoring, the sheer volume of connected cameras and things like that you might have to keep a place physically secure. There's not enough people potentially for that. So I think, they go really well together. And I do think there's some level of machine learning, whether you actively go out and like build it yourself or anything like that. I'm sure a lot of people won't have an interest necessarily in doing that. I think as many tools as are available to help kind of create this almost out of the box experience for them, and to help visualize that and understand what it means when they get these answers out of the platform, in order to do something with them. I think those two processes go so well for IoT because there's just not enough people.
Yeah, and you bring up a really interesting point in that in the IoT space, we're talking scale. We're talking tens, thousands, hundreds of thousands of assets that are connected and creating this data, this information. Obviously, part of that process has to be validating that data, because the old term garbage in, garbage out. If I accumulate a lot of data, which is useless data, but I'm building a model off of it, well, that does me no good. Do you see AI and ML playing in a role in that validation of data, looking at the data for consistency and making sure, yeah, this is what I expect to see, as opposed to, no, this is kind of strange?
Yeah, and it's a funny problem to look at, because you mentioned consistency there, which I think is a really interesting facet of the whole conversation. And what you really want, that's like a general machine learning process. I want to see anomalies in my data. That's what I probably have implemented it to try and detect, right? If the pressure on the pump suddenly goes up really high, and it's about to explode, I probably want to know about that and detect that. But at the same time, how do I know that it's not just another device, like sending, or the device has been compromised and someone's trying to get me to roll a truck for whatever reason out to that well, or creating havoc within my environment to try and either for monetary gain or for malicious intent or whatever it might be. How do you kind of tell the difference between that? And I think it becomes this sort of multi-layered approach. And I think there's several different ways in which you could apply AI and machine learning to IoT in order to get the best out of it. So you could take a look at data points, and you can say, oh, there's an anomaly, the pressure's just gone straight up, right? And we need to be mindful of that. But I think it also comes from trusting that data comes from a place of trusting the device. And I think the device trust nowadays is something that's really, it's tough. It's a tough question to answer sometimes. It used to be, again, quite binary. I present a credential and I'm that device. And now it seems like it needs to go a little bit deeper. And we need to kind of take a look at this evolution of security for these devices in order to be able to trust the data or trust the device so you can trust the data so you don't necessarily end up with that garbage in, garbage out process. It used to be you could connect between 9 and 5 maybe or something. There might be a limitation on that in terms of your device's authorization. Obviously, authorization not the same as authentication. Authentication is who you are, and authorization is what you're really allowed to do. But in terms of maintaining this kind of authorization state, maybe you said my factory is only running between 9 and 5. Nothing should be doing anything outside of 9 and 5, right? And that's quite a binary authorization question. And now it might be, it was for the last 2 years, it's been connecting in 10 times a day to do whatever job that it needed to be doing. And all of a sudden it's running 100 times a day. And it's still between the hours of 9 and 5. But there's something going on there that's causing the behavior, I think, of that particular device to change. So there's a big security aspect around indicators of compromise for devices. And those are things that, just like monitoring CPU, for example. Maybe it's used 25%. Everyone else is using 25% CPU to do their thing. They're just idle or whatever it is. And, you got one that suddenly starts using 100%. There's either something wrong or there's processes running on that particular device that shouldn't be. Using machine learning to kind of monitor the network traffic as well is something, because if you think about DDoSing or ransomware that might get in and try and find its way to other areas within the company through these connected devices too. I think monitoring the network card, for example, could be a good place to look as well. But you're really not necessarily trying to figure out how someone got in. You're looking potentially for those indicators of compromise to trust the device on an ongoing basis. So ongoing and continuous validation and authorization of these devices that are effectively providing the data to the platform and the processes.
Yeah, and that's, what you're really talking about here is identity theft at a device level. We know it as individuals that somebody may steal your identity and start to leverage that to do something nefarious. And you're putting this down at a device level and saying, well, it's still a possibility. We may very well have a situation where people will steal the identity of an asset and use that asset to do certain things. And how do you protect against that, right? This is really what one of the things that Device Authority is really focused on. How do you protect these field-based assets from this kind of attack?
Yeah, and it's important to remember that the attacks on these devices are also a bit easier depending on the physical security of where your devices are deployed. You spend all that money in the workplace to protect people with firewalls and physical security and things like that. And then, there might be an unattended location wherever you're deploying these devices. And the physical security is not there. People probably have better physical or easier physical access to some of this, depending on your use case. So I think it's critical to have these kind of device-bound identities and that continuous validation that I was just mentioning. So if as long as you're TPMs, I think play a really good role. I think TPMs from a hardware perspective really help bind identities to devices. A lot of the stuff that we see, the requirements this comes through, and it's got to be TPM, which is great to see. Back in, probably, I don't know what it might be, 5, 6, 7 years ago, again, when IoT, I think, was a little bit more of a, let's see what we can do with it, compared to the very serious thing that it is now. TPMs were never there. TPMs weren't on the requirement list. they weren't being considered. It cost an extra $3 or something on the bottom of the device, and I don't think it was really ever considered that strongly. And I'm happy to see that a lot more requirements come through for, your software has to work with the TVM, which we obviously do, but that helps bind that identity to the device, right? So you have the private key of or the secrets or API secrets, whatever it might be, stored inside this kind of physical tamper-proof location within the device. That's not just if I SSH in, I can, secure copy it out straight onto another device. So binding that identity to that particular device, I think, is always a great way to stop it being cloned and stop the devices from, like you said, digital identity theft or device identity theft, and just someone just copying it and just going doing whatever they wanted and impersonating that device and trying to send in dud values. But on top of that, the indicators of compromise and the continuous validation is also going to help you understand when not every use case is necessarily, copying of a key or a secret or whatever it might be. They could just take the whole device. If you think about retail outfit, hopefully the guy in the back looking at the monitors is watching all of them. But if you think of a retail outfit, you could go in and there's I don't know what it might be, a centralized hub for like managing the refrigeration units and things like that, and responsible for proxying all the data because they don't have direct internet access. Obviously, they would go to a hub, collects all the data, collates it, and would maybe send it all up to the platform or do something local with it and kind of give a summary. But, I could go in, I could take it off the wall, and I can walk out, potentially. So the actual monitoring and validation of those specific and individual devices is going to help you deal with or detect the instances in which someone gains access to a device, and instead of realizing that they can't copy the secret off it, just start using the device to send whatever they want. If that makes sense.
Yeah, but it's an interesting concept that in security, as it's applied to facilities, there are generally layers of security. So, for example, you might have a key card to get into your building. You might have to have a key code to get into a specific room. There are cameras. There might be security guards and other things in play. And you're not provided access to everything in that building. We often think in the world of IoT as security being native to the device. The device has, it's got a private key. It's got a public key. Maybe there's a token on there. And its own cert, and so on and so forth. But you kind of bypass it, but it's interesting. There's actually a physical security component to this too, because if you can reduce access to the asset so people can't physically get to it, that is that other layer of security. So in your case of the gateway, I have a gateway that's collecting data for a bunch of refrigerators. I may want to put that in a NEMA 4 enclosure, bolt it to a wall, and put a lock on it.
Yeah,
it's
absolutely.
not perfect, but it provides another layer to that process. It keeps people away from that device so they're not just getting into it or stealing it.
Yeah, absolutely. It's funny, now that you mention it, it kind of becomes recursive because then the physical access systems could also be monitored for using and feed data into machine learning processes to understand, I don't know who, my John Smith never used his card in that particular room before. Why does he have access? Or why is he going in there at 2:00 in the morning? The guy shouldn't even be at work. So it's kind of becomes this whole recursive sort of fountain of different ML processes that can really help drive for better security within your overall, implementation.
Yeah, and in fact, we see that in hosting environments, for example. There is the physical security as well as the firewall security and other components. You just can't get into a hosting center. You have to have access to that facility. So it is definitely a combination of those things. You need to look at the physical as well as the cyber side of the security component. So fairly broad set of topics, but really interesting. And for me, a little bit eye-opening thinking about the world of security, slightly different than I always have. But again, we are limited in our times here. So I want to wrap up with, do you have any parting advice that you would provide to people who are starting on this journey of IoT, and maybe even starting on this journey of, I've got IoT, but I'm getting now to, I want to be involved in machine learning and AI. Anything in that arena that you'd like to give them?
Sure. I mean, my first bit of advice would be to consider security from the get-go, just as a general thought. I joke sometimes that security is step 11 in the 1 to 10 of getting an IoT device or product to market, because people they say, we'll figure it out. Like, we just got to get it working, build a POC, and then if this POC works and it's successful, and then someone forgets to think about security, or they're trying to shoehorn it in at the last minute, and that's always a bad place to be, because you'll end up going back and redesigning a whole bunch of components and back-end services and things like that. But so security is a forefront, but just try as hard as you can to get that security right from the beginning, for the sake of your machine learning processes and the data that you're going to feed it. I think one of the worst conversations that you probably would want to have with the board is trying to explain why all of your data, you don't know how much of it is real, because you found some issue or some security problem with your particular devices, and now we have to go back and A, rectify security vulnerabilities, B, probably notify some regulatory authority, and then start recollecting data and effectively start from the beginning, because all those models that we trained on all this potentially bad data, and again, you don't know what percentage of it might be bad, and even if you do know what percentage, you don't necessarily know which data is bad from the good stuff. So I would say security is at the forefront, if only for the sake of not having to start again in 2 or 3 years' time with your machine learning data that you're collecting and trying to process and build models for.
It's interesting. You said it's step 11 in the process of a 10-step process.
Yeah.
The juxtaposition to that is when I speak with customers who are thinking about deploying IoT, or even better yet, the customers who we will deploy a connected asset to, security is question 0. It is the first question.
It's getting better.
The second question they ask, the third question they ask, right? So from a design perspective, it's very often at the end of the process. From an implementation perspective, it is the first, second, and third thing on their minds.
I would say it's getting a lot better, for sure. I mean, I mentioned the TPM example. Before, $3 was too much, and now people can't seem to get enough of it. I think it's a sign of real maturity in the industry, which is great. And it's definitely getting better. And security's getting involved a lot earlier in the conversation. But if there was anyone who was trying to push it off to step 11, then maybe reconsider that position.
And it is definitely an ongoing process. I think what we're starting to see trend-wise is it's not a milestone in the development program. It is a continuing milestone. Meaning there are releases after releases after releases. We continually make modifications to that security profile, so it's not a one and done.
That's absolutely right. Yeah, it's definitely evolutionary. I mean, last year, 25,000 vulnerabilities plus 25,000 plus vulnerabilities reported. So you only have to look at the size of that, and this year it's going to be higher. So absolutely, it's an ongoing thing. It's not just we're done and draw a line in the sand and let's move on to the next thing. It's an ongoing consideration.
I would like to thank James for joining us today. James, this has really been insightful. Kind of makes me rethink the security module, even though I've thought about this a lot. And I do see, to your point, I do see this movement in a new direction where people are starting to think about security first. In fact, our third in this series on security, we will be bringing in one of our customers, Fujifilm Sonosite. They just rolled out a program this year, and the interesting thing about that, and why we wanted to bring them into the program, is they started thinking about security when they were doing the bid. This was like before they even got into, okay, how do we roll this out? When they were thinking about how to bid this system out, they had security requirements in there that were actually quite unique for some of our customers. So it does prove the point, James, that maybe that security step is moving from 11, maybe down to 2 or 3, maybe 1 at this point. So really happy to see that. Hope you'll be able to join us for our next episode when we bring Fujifilm Sonosite in for that. And for those of you who have joined us today, thank you very much. This is Anthony Moffa, and this is Speaking of Service.
Thanks for listening to the Speaking of Service podcast, brought to you by PTC. If you enjoyed this episode, please subscribe wherever you get your podcasts and leave a rating or review. And be sure to check out other episodes to hear new perspectives on improving life for aftermarket professionals, service teams, and the customers they support. If you have a topic of interest or want to provide feedback, email us at speakingofservice@ptc.com or visit us at ptc.com/speakingofservice.